Are you ready to dive into the world of project management? Hit that subscribe button as we explore how to stay relevant in an agile workforce. Quality is a key focus in project management, and it includes the totality of the features and the characteristics of a product, a service that bears on its ability to satisfy the stated or implied needs. It represents what the stakeholders expect from the project and the characteristics that the project fulfills and its requirements. Its implied quality are inputs for devising those project requirements, because ultimately we're here because we're trying to deliver on those requirements. In business, quality should be feasible, adaptable, and measurable. Let's talk about the quality management plan. This quality management plan ensures that common understanding of project quality sets the standards and defines parameters to assess the project quality. We're going to talk about the quality process. We're going to talk about stages and also some descriptions within those stages. First, quality planning. Quality planning is where you identify the standards that apply to the project and decide how to meet those standards. And you start by focusing on establishing sponsor or customer requirements, designing products or services that meet those requirements, and establishing those quality goals. It also helps with defining the processes, establishing the controls used in those monitoring processes. Quality assurance, which is different than quality planning, is evaluating overall project quality regularly and systematically. So quality planning is identifying the standards that you're applying. Quality assurance is evaluating the overall project quality regularly and systematically during the evaluation process so that all the stakeholders have confidence that the project will meet the identified quality standards and the legal and regulatory standards. Quality assurance is a prevention method. We're also going to learn about quality control, which is different than the other two. This is where you're evaluating specific quality against quality standards and identifying ways to improve that quality and ways to eliminate the causes for unsatisfactory quality. Quality assurance is conducted during the monitoring and the control phase of the project. So quality assurance happens during that monitoring and control phase. We're also going to talk about variables affecting quality. These are things that you want to look out for because this can impact quality on your projects. Cost, if you have low costs or high costs, these are variables that can affect your quality. Time, degree of hazard. These are things that you want to think about, reflect about, how these can impact quality within your projects. Pressure to get to market. You're getting pressure to get to market. Or design. Unclear direction. Issues with vendors. Burned out team. These are issues and variables that can affect your quality on your project. These are things that you're going to want to prevent. Now we're going to get into some theorists because we're talking everything about quality. You can download this study guide. And this is perfect for either CAPM or PMP because ultimately all projects are going to have a standard of quality that they're going to be measured against. We're going to talk about some theorists. You want to make sure that you understand. You don't need to memorize who these theorists are, but understand what they contributed to quality standards. So we're going to first start off with Edward Deming. And just remember Deming and the Deming cycle. And the Deming cycle focuses on continual process improvement in which quality must be continually improved to meet customer needs. Deming cycle, continual process improvement. Juran, Joseph, and it's the Juran trilogy. This breaks quality management into quality planning, control, and improvement, leading to breakthroughs and improvement that raises the quality bar to unprecedented levels. So this is breaking it into those three components that we talked about before. And then Philip Crosby, this is the four absolutes. It's four absolutes with Philip Crosby. Quality is conformance to requirements rather than a measure of how a product or service is. So conformance. Quality is achieved by prevention rather than inspection. Everyone must work to a standard of 0 defects. Quality can be measured by determining the cost of quality. Quality can be measured by determining the cost of quality. Those are the 4 absolutes. And then we have Taguchi's method. Taguchi's method emphasizes that quality should be designed into products so that factors that cause variation can be identified and controlled. And then we have Bill Smith's Six Sigma. Bill Smith, Six Sigma. And remember, he's the only one with an S in his name. He emphasizes that responding to customers' needs and improving processes by systematically removing defects. That's Six Sigma. Systematically removing defects. We're going to learn about standards and regulations. Standards, they're voluntary guidelines or characteristics approved by a recognized body, such as an international organization for standardization, such as ISO. Regulations, on the other hand, these are compliance, mandatory characteristics for specific products or processes. These are mandatory. Standards, voluntary. The cost of quality. This refers to the total cost of effort to achieve an acceptable level of quality in a product or service. It includes all the work necessary to ensure conformance and all the work as performed as a result for non-conformance of the requirements. So think of that cost of quality, all the work to ensure conformance of the work performed, and also non-conformance. There are 4 types of costs associated with quality. You have prevention costs, appraisal costs, you have internal failure costs, and external failure costs. We're going to talk about all 4 of them, but you want to understand how 2 of them internally kind of break down. So prevention and appraisal costs. These are called conformance costs. Conformance costs. These are the top ones that we're going to be talking about. These are amounts of money that you spend to avoid failures, avoiding failures. You're going to put this money out there to avoid failure, prevention costs. And then we also have the internal and external failure costs. These are non-conforming. These are amounts of money used to rectify errors. So the first set of 2, to prevent errors, avoid errors. And the second set is to rectify. We're going to go through the types of costs and the cost of quality. Under prevention costs, these are upfront costs of programs or processes needed to meet customer requirements or design and quality. And examples include design plans, quality plans, employee and customer training, process evaluations and improvements, vendor surveys, and other preventative activities. We also have appraisal costs. These are costs associated with evaluating whether the programs or processes meet those requirements. And this includes inspecting, testing, design review, and then also deconstructive testing loss. Internal failure costs. These are costs associated with making a product or service acceptable to the customer after it fails internal testing and before it's delivered to the customer. So this is before it's delivered. This is scrap or rejects, design flaws, rework or repair, defect evaluation. And then external failure costs. This is cost due to rejection of the product or service by the customer. This is product returns, liabilities, evaluations of customer complaints, maintenance costs, corrective actions, and loss of contract, none of which are good. So we're also going to go through some checklists. Checklists can either be simple or complex. It's not something that we're going to go too far in depth. Flowcharts, they are diagrams that show relationships of how various elements in a system or process, and this can assist in a team effort for identifying potential quality problems and also how defects, cause and effect diagrams. And we're going to talk about those diagrams in more detail. These are types of flowcharts that are organized by category, and they provide a structured method to identify and analyze potential causes of problems in a process or system. And they organize potential causes or problems into defined categories. And this promotes identifications of the potential problem. You also have control charts. These are graphs used to analyze and communicate the variability of processes or project activity over time. This can help show the potential capability of subjecting a range of variability in a process. So the range of variability can assist a project manager in determining whether common or assignable resources cause a variance. And if process variability fluctuates around the average or statistical mean, the process shows minimal variability and is said to be stable. As I also mentioned in process flowcharts, process flowcharts include process diagrams or system flowcharts, and they show the sequence of events and the flows of inputs and outputs between elements of a process or system. There is a definitive beginning and an end, and there's also decision points that are called out with actions that have to be taken as a result of that decision. So remember, with these process flowcharts, you have to have an action from that decision. So next, we're going to talk about upper control limit. So we're going to talk about upper control limit and lower control limit. Upper control limit and lower control limit. Upper control limit and lower control limit is determined by taking samples from the actual process and calculating the statistical mean. The upper control limit should be 3 statistical standard deviations above the mean for respective processes. The lower control limit will be 3 standard deviations below the mean. It indicates instability because there should be measurements that should not exceed that range. The 7-point variance. This is a rule that indicates situations outside of statistical control. When 7 more consecutive points lie on one side outside of the mean, it suggests that there should be a shift in that mean. So remember, if there's 7 or more points that are set consecutively outside of that mean, you need to shift that mean. Benchmarking. Benchmarking addresses the evaluation of groups. It's used to identify the best practice or to meet or exceed them. This can be conducted between identical processes, or it can be conducted with like or similar processes. It commonly determines products or services to offer and features that should be included. Processes used by other groups to achieve customer satisfaction, metrics or goals used to processes or products to achieve customer satisfaction. Quality metrics. Quality metrics are the actual value that describe the measurement of quality control processes. It determines which elements of the project are going to be measured and how they will be measured and how they will be factored into the project. This includes timely performance, budget control, defect density, rate of failure, and test coverage. And then process improvement planning. This is the process of analyzing areas for improvement in projects and enumerating an action plan based on the project goals and identified issues. This involves operational theories, project roles and responsibilities, describing process improvement objectives and activities, determining process improvement activities, receiving additional approval from stakeholders and senior managers, identifying long and short-term goals, identifying risk and resource requirements, and creating process improvement plans and executing that process improvement plan. Like I said, this is a study guide on quality control and a quality control plan. This is a key process and this is the quality management plan. You can download this study guide on the EverTech and the project leaders page. Once again, please follow, subscribe, and share. We'll have more videos on similar topics. Look forward to seeing you. Thank you for joining us today. If you found this video helpful, please like, share, and subscribe to this channel for more project management content. See you on the next one.